Okay, Alan, thank you very much for giving up your time again to come onto the podcast.
Thank you for having me back again.
Yeah, you are now the third repeat guest on this podcast, so you join an elite few.
Yeah.
And what have you been up to since we last spoke about? Still working on this monstrous PhD, I guess.
Yeah, that really has been it. I have been very much stuck in data processing and analysis for the study that we finished in August. So there's a huge, because it was a controlled lab study in people, we have a huge amount of data. So, just as an example, we used continuous glucose monitors, which kind of insert into people's kind of abdomen, and will take a glucose measurement every 5 minutes for 6 days. so,
Right.
so for 13 people, we have that amount of data over the course. Now, obviously, we don't need to use all of it, but you can imagine that it's a lot. Or for the energy expenditure measurements that we were doing, we had a 30-minute baseline measure and then 10 minutes every half an hour for the whole day for 16 hours. So again, for each individual, that's done in 1 minute increments. So that there's just a lot of data. So it needs to be organized, and now with some of it, we're getting to the point of being able to start to analyze it, and that'll be exciting. I think the glucose and the energy expenditure are the two things we most are kind of interested in, because certain previous studies in the kind of timing intake chrono-nutrition space have suggested that there may be differences in energy expenditure over the course of the day, and that it naturally fluctuates. And because we did such an extreme forced jet lag basically on people, where we delayed everything by 5 hours,
right,
hopefully we should be able to see a difference in that context. And then the blood glucose stuff will be interesting also, because we do, one of the most well-established aspects of chrono, I guess, biology and nutrition is we do have very distinct differences in our sensitivity to glucose and our insulin action at different times of day. So yeah, looking forward to starting to crunch some numbers with that stuff.
Yeah, well, I mean, tell us a bit more, I guess, about the study that you have done then, and what you're looking to create, because this whole podcast is on this idea of chrononutrition, which is what you're deep within. So what have you done to these people? What are you trying to find out?
What did you do to them?
What did you do to these 30 people?
So
these poor people.
We did, obviously, there are various ways you can do research, and there's no such thing as the perfect study. A lot of what you would call free living studies, where people are told to follow a diet and are told to maybe follow certain behaviors within that, like eating more for breakfast versus dinner, have been under conditions where not all of those aspects of their diet were controlled, and not, they weren't supervised. So they were following the plan, so to speak, but they were doing it in their own lives. And a number of studies have found that there has been greater weight loss with people consuming the vast majority of their daily energy, like their biggest meal of the day at breakfast, and then smaller dinners. There was a couple of controlled studies by a group at Bath that suggested that there is greater energy expenditure when you consume a big meal at breakfast. And they found that energy expenditure came from additional physical activity, basically, but low intensity. So people were generally more physically active with breakfast, following breakfast. And there's all of these interesting kind of findings that are more at a point now where we can't really draw conclusions from, but we need to pick deeper into what's going on. So our study was in conjunction with the University of Aberdeen. They're currently running a intervention over 10 weeks, which is a weight loss intervention, but unlike the previous studies, they're controlling every aspect of diet So participants, all of their food is made for them in a metabolic kitchen at the university's research, the Raud Institute. Participants collect their food on Monday, Wednesday, and Friday for the subsequent days. So it's very tightly controlled on the diet front. But then secondly, for energy expenditure, they're using doubly labeled water to measure energy expenditure. And for people listening, doubly labeled water is the gold standard way of assessing energy expenditure in humans in free living conditions. So it's basically 500 mils of water that's got a particular tracer added to it, and you drink it, and you can trace that tracer as it goes through their body and is eliminated in urine. Right. And you can actually tell based on the difference in carbon in CO2 production how much energy they've actually been expending. So it's a really accurate way. So this study is going to be the most comprehensive study that has been done in looking at this difference in whether timing earlier in the day versus later in the day impacts on weight loss, and then also underneath it all, whether it impacts on things like blood glucose parameters and stuff like that. Mm-hmm. And our study then was trying to dig more into the mechanistic, the circadian variations in these factors, like your energy expenditure and in your glucose tolerance, and even in your blood lipid profiles, so your blood circulating blood fats. And so what we were doing was people were coming into the lab having spent the previous week on a specific kind of sleep-wake schedule. And then for the first 3 days in the lab, they were on UK kind of, shall we say, sleep and wake timing that was similar. And they were on a normal UK meal timing. So we were, let's say, if we're just averaging it, they were waking at, say, 7, having breakfast at 8, lunch at 1, dinner at, say, 6 or 7, and then going to bed at 10 or 11, depending on their timing was all individualized. And then suddenly on the third day, they were kept awake until, and this is in a very controlled, purpose-built sleep laboratory, they were kept awake until there's no windows. They don't see windows, right?
Amazing.
They were kept awake till 4 or 5 a.m. And then all of their meal timing and their sleep and wake schedule, all of their behaviors were then delayed by exactly 5 hours. So they were then having, for example, waking at 11, having breakfast at midday or 1, lunch at 6 or 7, and dinner again at 11 or midnight. And what that means is that on those delayed days, their breakfast and lunch comes at the same clock time as their lunch and dinner did on the aligned day. So we should be able to look specifically at the same clock time meal, but when their internal rhythms are now disconnected from that kind of alignment. Sure. So their light environment was controlled, and they're wearing these blue light blocking glasses in the evening. The sleep labs are pitch black and soundproof, and they would be in there for 8 hours in complete darkness. And then they'd be woken up, and then they would start the day again. So we did that because it was so tightly controlled, you can't really do very long studies under those conditions. So they were there for a total of 8 days, discharged on the 9th. And so what we're trying to look at is, if something is a circadian rhythm, what that means is it's a derivative of the Latin term circa, meaning around, and dies, meaning day. So around the day. So every organism on the planet, humans, flies, mice, whatever, all have these rhythms that correspond to the light and dark cycle based on the Earth's daily rotation. And those rhythms, if we were to take a bunch of listeners and stick them in a pitch black cave, because they've no input, there's no light, and it's complete darkness, eventually your internal rhythms would disconnect from the exact 24-hour day that we have in terms of clock time. And in humans, they would run over 24 hours. They'd be about 24 and a half hours. Other species, mice, for example, if that happened, their internal rhythms, their natural period of them would shorten. And the reason these cues like light and food timing are so important to any organism is they allow us to synchronize those internal rhythms to the external environment. So by having daily light exposure, by having meal timings during a period that also corresponds to the light exposure part of the day, the waking, the active part of the day, these processes all help these internal rhythms to synchronize to a 24-hour period. Mm-hmm. So everyone will have experienced what happens when we really disconnect from our immediate external environment from jet lag. If they've ever traveled east or west, you travel, maybe the flight is 8 hours, but you've crossed multiple time zones. And you're now at a point where your biological clock expects it to be 7 a.m., expects you to be just waking, expects you to be maybe getting food. But in fact, you're now in an area of the world where it's Sydney and it's 8 p.m., right? So there's this complete disconnect. And we know that there's an adaptability to the circadian system, because once you start adopting your new cues in your new time zone, you will eventually adapt. But what this field is quite interested in now is the effects of maybe less extreme but more chronic disturbances to that system that occur from the natural environment, or the lack of a natural environment, and our operation and daily lives in cities, in very artificially lit environments, disturbances to people's meal timing that occurs with being, for example, a late chronotype, people who are predisposed to stay up late in the evening, may, because they have to force themselves to wake up in the morning for work or for school, they tend to be the ones who are most, in terms of the research, it seems, prone to the adverse effects metabolically. And they may skip breakfast, consume much of their energy in the evening time, and end up kind of forced into a set of behaviors that are not good for their metabolic health over the long run.
Sure. Yeah. So, I mean, it's a huge topic, isn't it? And it's all emerging at the moment. Because as you said, we'll have experienced it ourselves with when we take a trip east or west, that's a few hours. Yeah. And we experience jet lag, but we get over it in a few days. But I mean,
was anything in that explanation, do you think, would not be clear for listeners? Is there anything I should clarify?
I guess it's no. It's a, like you gave a really clear picture of what it is you're trying to do with these subjects in your lab. I guess what you're looking at then within these subjects is what are these differences within their metabolic health markers and stuff that you're inducing with this time shift that they're unable to adapt to.
So let's say that we, on the days that they're aligned, that we see that they have quite a high rate of energy expenditure in the morning, and that their thermic response to feeding, like how much energy they burn digesting food, there's a suggestion that is enhanced early in the day as well. So whatever their levels would be when they're aligned, when we misalign them and suddenly they're now having breakfast at midday when they were having, or 1 p.m. and they were having lunch then the day before and the day before that.
Yeah.
What we potentially be expecting to see is a blunted response to that, because their rhythms are now offset. So they don't have the same level of energy expenditure. They don't have the same thermic effect of feeding. Their glucose response, their blood glucose levels in response to that meal remain higher over the 2 hours that blood glucose levels would usually come down, because their glucose tolerance is now impaired from this delay. So they're the kind of things we're interested in. But I think what I should have clarified now, because you mentioned the jet lag thing, because we know your rhythms will catch up.
Yeah.
But we know that there's a rate limiting time every day that they can catch up, which is why you're not just over jet lag in Sydney after 1 day. People can be messed up for 5 days after. Yeah. A lot of chrono studies before ours would do very acute shifts. So they would maybe have 2 or 3 day studies where they have people normally aligned on one day, shift them on the second day, and then return them on the third day to kind of their normal timing. What we wanted to do was, after we shifted them, rather than bring them back, leave them on that new light dark cycle, sleep wake cycle, and meal timing cycle for 5 days.
Right.
So we can see the time course of how quickly these rhythms catch up and
Sure.
how long they're impaired for. So that's a novel experimental element of our study that will be interesting to look at and compare it with some of the other work in the field that was more shorter term.
Sure, because as you said, you're then just going to see how quickly they catch up and how quickly they adapt. But
Right.
unfortunately, I guess for the people who are, as you said, late chronotypes, and for those out there that have read Matthew Walker's Why We Sleep, they'll sort of be appreciative of this fact, is that there are people who want to stay up later and then get up later, but they are forced to get up earlier because of work or school. So really, for those kind of folk, what can they actually get away with doing if their current habits are to eat later at night and then skip breakfast, but that's not going to be best for them?
Be self-employed.
yeah, that's it, isn't it? Be self-employed and demand your own working hours.
It's a conversation. I think is the first thing to mention that I think is really interesting is that this idea of late chronotypes. It does seem from the research that people who identify as late chronotypes, the numbers have actually increased over the last 10 to 20 years.
Right.
And the reason that is, or the hypothesis that is behind that, is the circadian system requires and relies on really high contrasts, high strength contrasts. So if we were to take a bunch of people camping that self-identify as, I'm a really late type, I'm a really early type, a lot of them, they might not all come back into neutral type, but they would, it seems their extremeness would be attenuated somewhat. And the reason is natural light has such an intensity and a wavelength that we can't really replicate. Indoor office lighting does not even come close to it. And so just as an example, so our listeners can kind of somewhat quantify this in their head. If we use lux, which is a measure of light intensity, generally our circadian system needs a minimum of like 2000 to start getting an entraining effect, 2000 lux. If we go outside on a bright day, you could be looking at 100,000 lux plus. Even on an overcast day, you could get 10,000. Average office lighting is 500.
Right.
So we're not getting these high contrasts. And then if you were out camping in the middle of the woods, you would have that really high contrast in the day of brightness, but then the sun dips and all of that wavelength and intensity comes out of the light in the environment, and it's dark, and suddenly we have this massive contrast to darkness. If you were able to witness that transition from sunrise to sunset, the transition in light has a massive impact on your internal circadian system that starts to signal to your internal biological rhythms and processes that it's transitioning to night, that it's transitioning to resting, fasting, sleeping. So melatonin will increase and all of this stuff. Modern environments don't give us those big contrasts.
No.
So this gray area of external stimuli for the internal circadian system. And when we factor that lack of high, strong contrasts with social habits, people tend to socialize late on weekends in particular, and really erratic meal patterns is a feature of a lot of people in kind of Western industrialized countries. They all seem to add into this mix. So late chronotypes are, and how we determine the term that's now emerging in this area of research is called social jet lag.
Right.
We've talked about jet lag. Social jet lag is the difference between someone's midpoint of sleep, or their sleep timing, when they would go to bed and wake up on free days when they're able to self-select, versus work days. And the greater the degree of social jet lag, you can calculate a social jet lag score,
Mm-hmm.
the more there is an association with increased adiposity and diabetes in particular.
Sure.
And a recent paper looked at diabetes and chronotype relative to sleep duration and other sleep habits, and chronotype was independently associated with diabetes.
Right.
So even though sleep duration was the same, late types were more prone. So we have these associations. They're really interesting. What it suggests is that this disconnect between people's desired biological timing and their enforced social timing is an issue. It's difficult to try and frame advice for this area right now. We know that teenagers have a shift in their chronotype to a later timing during their adolescent years.
Mm-hmm.
There has been a couple of schools that have done experiments changing the start time of the day to later morning, and seen significant improvements in test scores with the kids because they're cognitively performing better. And then when we look at the typical 9 to 5, so I mean, that's a byproduct or a hangover, probably is a better term, from the Industrial Revolution. Like there's no specific reason for it.
No.
So I think a lot of these conversations are more for now in society, like how do we want to organize time? A lot of companies let people choose their timing now in terms of work hours and stuff.
Yeah.
I think there's some big questions there for how we can help people function in society without imposing timing on them that's discordant with their internal rhythms.
Yeah. Because I mean, more and more companies are looking more into remote work in general. Like that's definitely a big craze in America that's coming through.
Yeah.
But then, on top of that, you could have more remote work, but then more flexible time, as you said. So people could go in at 7 if they so desired to then leave at 3, and someone else could go in at 11, 10, 11 and leave at 6, 7, whatever.
Yeah.
Or 7, 8, however that works. Because then it's more in tune with them. But I guess it's interesting what you said of like, if we took everyone back to nature and actually threw them out there and was like, right, you're going to rise with the sun and go to sleep with the sun, you'd probably find people more middle grounding rather than being like, I'm a night owl, so I'm going to stay up and watch Netflix until 2 a.m. It's like,
and the thing is, even if we took, I mean, every study that you see that uses the chronotype questionnaires, most people still do self-identify as neutral, neither extreme morning or extreme evening. You used to get more morning than evening, and now, like I was saying, there's been this shift where now you get more people identifying as evening types, and there's a lot that could go into that, and partially it could simply be because people just don't get enough of that high contrast light exposure in the early part of the day. And then when you add in social timing as well, where people, Friday comes and maybe they've been in bed at, I don't know, 10:30 every night that week because they want to get a good night's sleep for work, but then they're out till 2 a.m. or something like that. And so they've got that legacy effect of sleep curtailment into the following week where they're simply tired. And so I think a lot of people say, I'm not a morning type. I'm tired in the morning, but you have to factor in whether they've been out till 3 a.m. Friday and Saturday night.
Yeah.
Are they actually just tired in the morning because they're not a morning person, or are they just suffering a legacy effect of curtailed sleep?
Yeah. Have they just got social jet lag, and then it continues on?
Jet lag. It's not that they're not a morning person necessarily.
Crazy cats.
Yeah, like it's fine. We get away with all of this when we're 22. We don't get away with it when we're 35.
You don't get away with it when you're 29 either.
Right. You hear, like the funny thing, when friends have kids, for example, and they might for the first kind of 6 months talk about, oh, they're not getting any sleep and kids waking to feed and all sorts of. Children, when they're first born, don't have a circadian rhythm yet.
No.
It takes a few months to form, which is why they will literally be awake at all hours demanding feeding.
Yeah.
With no regard for mom and dad's circadian rhythms. So, yeah.
I think It's just a super interesting topic, because I guess this whole idea of having bigger meals earlier in the day, where the day is sort of at its brightest. It's that idea, I guess, of, our energy is highest sort of mid morning, and then kind of
Right.
scoops down as the day gets shorter. But I mean, in terms of practical application, does that mean right now it's like pitch black outside, and it's
Right.
20 to 5 at night. And you're just thinking, so does that mean that as we head into winter, particularly in the UK, with our shorter days, we should be pushing things earlier meal wise, or is it about finding something that works for you?
Not really. I mean, I think with the meal timing and the calorie distribution thing, I think we've a bit of a ways to. I think the one thing that we say is, like, there was a lot of interest in some studies that came out that did find a massive difference in weight loss, but they were free living interventions. And one of the interesting observations from those, and a lot of them came from the same research group, was that they measured ghrelin, which is a circadian appetite. It's an appetite hormone, signals hunger from the gut, but it is a circadian hormone, in the sense that it has a circadian rhythm and it peaks in the evening. And so it's one reason why restricting energy earlier in the day can predispose people to overeat in the evening, because you've under-consumed energy, and then you come home in the evening at a time when you're tired, long day at work, and you have the circadian peak in hunger and appetite.
Right.
But one of the effects of consuming a lot of energy earlier in the day is you actually suppress that ghrelin rhythm. And so when I read those studies, and I was like, okay, well, we know that this isn't energy balance hasn't gone out the window. What could be underpinning this difference? They obviously consumed less energy overall in that high energy breakfast group. What could have made them have done that? And I found the suppression of ghrelin quite a compelling potential reason for why they ultimately consumed less energy. They simply weren't hungry in the evenings. And that could be one benefit to people in terms of structuring their diet, particularly if they are the type that does find, kind of the mindless opening of cupboards in the evening. And I think that the other element that is quite clear now from a lot of the research that has looked at rhythms in glucose response, you get a really significant reduction in the glycemic responses that you have. So how much blood glucose peaks in your blood, and also the insulin response that's needed to return your blood glucose levels to normal over the course of the day when you have a big carbohydrate containing breakfast. And you end up with this really nice profile of your glucose rhythms if you have 3 meals, where you do get a really high peak after the first one, but then the peak after lunch is lower and the peak after dinner is lower again.
Right.
What it means is that someone's whole day, over the course of their 24-hour period, their overall blood glucose levels, in terms of how much there has been in circulation over the course of the day, is much lower. So I think we're conditioned in nutrition, because, obesity epidemic, all that jazz, to view everything in terms of success, in terms of research, through the lens of weight loss. And if there's no difference in weight loss, we don't care. And if there's no difference in fat loss, we don't care. The chrono stuff is not suggesting that there is that a calorie isn't a calorie, for example. But I think we would be throwing the baby out with the bathwater if we assumed that just because there isn't a difference in absolute weight loss, that there's no difference in any parameter that's relevant to human health.
Sure.
There is consistent differences, like I said, in people's blood glucose tolerance levels. One of the reasons for that is what's known as the second meal phenomenon. And what that means is that when you have a first carbohydrate containing meal, there's a suppression of the free fatty acids that you would have. So let's say you've gone to bed, you had dinner at 8 p.m. You went to bed at 10 p.m., 2 hours after your meal. We know that what happens while you're asleep is you're fasting. You'll have processed that meal fully by the time you're kind of asleep, and well, by the time you're about kind of like 1 a.m. The peak that our body has in circulating blood fats, in free fatty acids, and in triglycerides happens during our biological night. And that makes sense because we are fasting, so our fat tissue will be mobilizing fat and releasing it. But we also have a natural circadian peak in their circulating concentrations. So when you wake up in the morning, you actually have quite high levels of free fatty acids circulating. Mm-hmm. The intermittent fasting crew used to love that because they were like, right, that's why you skip breakfast, because you oxidize all this fat. But we know that actually no, because if you get to the end of that day, it's still going to be 24-hour energy balance that determines how much fat you've actually oxidized. Mm-hmm. But one of the things about the circadian system is that you'll have a lot of biological processes offset each other. So our rhythms in glucose metabolism are all very much tied to the early part of the day. Glucose and fatty acids and fat circulation have oppositional effects on each other. So when glucose is high, we suppress fatty acid mobilization and oxidation temporarily. So that's why we have the circadian peak in circulating fats at night, mm-hmm. and we have the circadian peak in glucose tolerance and activity early in the day. So when you have a meal early in the day, you suppress those circulating free fatty acids. And for that reason, your pancreas is able to have an insulin response in response to your second meal that is much more kind of attenuated, mm-hmm. and that your blood glucose levels are consequently lower in circulation after that meal as well. So they call that the second meal phenomenon. It's very important, it seems, for diabetes progression and management.
Yeah.
And part of the reason that it's important is because elevated free fatty acids contribute to insulin resistance. And so by suppressing free fatty acids in the morning, you have this beneficial response to glucose and to blood sugar in subsequent meals, and to the obviously the glucose that's consumed through carbohydrate. So that's one benefit that is an underlying metabolic health benefit that mm-hmm. you see independent of weight loss, and that you see beyond whether weight loss is the same between two groups, that I think is something important that we should factor in. I think the other thing as well that's important potentially is the behavioral aspect of the impact of consuming higher energy earlier in the day. Mm-hmm. So are people going to be more physically active? Are they going to have a suppressing effect on their appetite later in the day and simply not be hungry and all of this stuff?
Yeah.
So there are interesting avenues there that we still need to fully explore in this field. There's no black and white answers right now. The one thing I just caution people who are interested in it is not to assume that because there isn't a difference for weight loss, there's no difference in anything.
Sure.
And we know from some of the research looking at sleep curtailment that you might have the same total weight loss over a given period, but the body composition changes of that weight loss can be tipped in favor of lean mass or fat mass relative to how good and how long someone sleeps. So yeah. if you have bad and sleep less and sacrifice sleep, you end up losing the majority of that from lean mass, and you mm-hmm. don't lose it from fat mass, and the opposite then when people do sleep properly. So that's something to consider as well. And yeah, I think that there's definitely, the other thing that I think is really important, because I do get asked this a lot, people always say, well, does this mean breakfast?
Yeah.
Not necessarily. One, we can't really say that right now. Two, one of the problems with the research around this area is there's never been a definition of breakfast.
Yeah.
Break the fast. What does that mean? So some people have tried to define it as, oh, well, it's calorie intake within 2 hours of waking. That's not a bad definition. It gives leeway to people relative to their chronotype as well. If someone gets up at 9 and breakfast for them is then at 11, for example, or if someone gets up at 6 and they have breakfast at 8. So it's a bit of a better definition, still not perfect. When you look at different cultures as well. You see different patterns of energy intake. So if we were to do a chrono study in Spain, we find a pretty light energy breakfast, but quite a high energy lunch. The bulk of their energy would come in the middle of the day.
Yeah.
And you do see cultural differences in that. In the UK and certain Western industrialized countries, though, what we're seeing now is the vast majority of daily energy coming in the evening. So up to 46 to 48, basically half of total daily energy in the UK in population demographic trends comes in the evening. So that's, you know, a whole different kettle of fish to consuming that equivalent earlier in the day, or more than that earlier in the day. So what I think is important is, it may be at this point difficult to say that a lot of your energy has to come at breakfast, but the research would probably support right now most of your total daily energy coming in the first couple of meals, and how you distribute that less relevant. And I would probably say loosely as a time before, say, 3 p.m. If the bulk of their daily energy comes before 3 p.m., I think broadly speaking, that's probably on a par or on kind of relatively consistent tracking with our internal biology.
Sure. Yeah, I think, as you said, some of the really interesting stuff that's coming out of it was that idea of ghrelin being suppressed later on in the day, and that idea of, so people having a more, I mean, I guess it just comes down to having a more consistent meal pattern. Like if they have something within a couple of hours of waking and then something a few hours later, and they're actually eating like regular meals at regular times, they then have a more regulated blood glucose response and less hunger later on in the day. Because I think everyone listening to this could probably attest to the fact that, oh yeah, I wake up and I have to rush out for work and I'm not usually hungry, but then a few hours later I'm like raving that, like, the cupboards at work or whatever, or just eating all of the biscuits and stuff, and then when I get home it's the same thing, and it kind of just leads them to eat shitty food, which drives up energy balance and blood sugar, whatever. So this is kind of just a way of like, look, let's not, as you said, it's like we still know that calories matter and food quality overall matters, but there's just this idea of eating a little bit more consistently will have good improvements of health markers and overall rhythm.
Right. And here's the thing. So many of these studies are designed around weight loss, right? And, you know, generally speaking, yes, once there's an adequate energy deficit, people are going to lose weight. And in the short term, there may be an improvement in metabolic health, but it's the underlying processes over the long term that are probably of more interest. But here's what people always kind of fall back to. Well, if someone ate 50% of their energy at 9 p.m. and someone else ate it at 9 a.m., but they were both in the same energy deficit, they'd lose the same amount of weight. Right. What if they weren't in an energy deficit? Right? Let's flip that question for itself. Like, until we do the research, we can make hypotheses based off what we see at observations from observational research, like what the findings there. But most people aren't adhering to a MyFitnessPal tracked energy deficit in the general population. So the relevance of this is actually, we'd be more informative to look at overfeeding studies relative to late versus early. And there are some studies in that area, but not a huge amount. But the bottom line is, if you compare two people doing that in energy balance or in energy excess, what would the degree of increase in adiposity be with someone consuming 50% at 9 p.m.? Because we know your glucose tolerance is impaired. We know your capacity to break down and utilize and actually burn off fatty acids are impaired at that point. We know that your circadian peak in fatty acids is in the biological night, and you're going to be digesting this meal into that. So there is absolutely a plausible biological argument that that person would store more of that energy in that time frame, and over time have a greater increase in body fat and adiposity than a person consuming that same amount of food at 9 a.m.
Right.
So I think sometimes, again, we we can miss the forest for the trees by focusing on what would the effects be in an energy deficit. It's like, well, let's assume for 1 second that the vast majority of the population are not in an energy deficit, which they're. So what's the consequence of consuming the vast majority of your daily energy in close proximity to bedtime? We do have one nice study that looked at this. It was only cross-sectional, but what it did was it measured objectively, the best measurement that you can get, measured internal circadian phase. So this is what's known as your dim light melatonin onset. So if we locked you in a dark room for 48 hours and measured when your melatonin peaked, that gives us a good, well, the most reliable indication of what your internal circadian timing is, your kind of internal biological timing.
Right.
So this study did that measure at the start, and then looked at and compared overweight people versus lean people, and compared them for when they distribute energy.
Right.
And people who were overweight consumed more of their daily energy, and their midpoint of calorie intake came later in close proximity to their dim light melatonin onset.
Right.
So they were eating closer to their internal biological night.
Yep.
And that's really interesting.
Yeah, because that's more real world scenario,
right?
As you said, because all of our research, as you said, is pretty much obsessed with weight loss. We're all like, it's almost as if every researcher is still like, let's try and find the magic bullet for weight loss to give to people, because that's where all the money would be, isn't it?
Yeah.
If you could say this one magic trick can have you lose weight faster and easier, everyone would be all on it. Which is obviously veganism, as we both know. But it's real world scenario. Yeah, let's not get into it. We've done extensive things on that. Yeah, it's real world scenario. It's that idea of, if these people are free living individuals and they're just eating ad libitum, and they're going to be overeating. Well, if they are overweight, when are they eating? Oh, they're actually, observationally, they are eating more outside of their circadian rhythm compared to people who are of a lower body weight.
Right. And the really interesting thing about, again, that group produced 2 papers looking at similar kind of outcomes. But when they looked at calorie intake relative to clock time, 4 p.m., 5 p.m., relative to clock time, those associations weren't evident. It was only when they looked at it relative to the participants' internal circadian phase,
right, sure,
that it became evident. So this may be less about clock time and more about individuals' internal rhythms. But the one thing we do know is that although there will be individual differences in your internal timing, there is a point at which those differences become almost irrelevant. Midnight is midnight is midnight. Like there isn't someone that can say, well, I'm a late chronotype, so I have dinner at midnight, because we're out of the shade of gray then in terms of biological timing, and we're into distinctly like, no, this is well into the biological night.
Yeah.
So we're talking more about the kind of active waking period and the nuances within that, and where does it start in the late afternoon into the kind of early to later evening, and where is that difference in there, and we don't know necessarily yet.
No.
But what is suggesting the most relevant determinant of the relationship between timing of calorie intake and weight gain is proximity to someone's internal kind of biological night, as opposed to just what time it is on the clock, so to speak.
Sure. And as you said, that would be, you'd have to go and get that analyzed, wouldn't you, to know that specifically, or have a pretty good reading of yourself, rather than thinking, oh, I'm just a late or an early,
right?
Or go back to nature and find out for yourself when you naturally wake up and go to sleep.
Right. And there was a group in Spain that published a paper during the summer where they looked at what they called a chronotype adjusted diet.
Right.
So they did chronotype questionnaires at baseline, And then, so they didn't use the objective measurement of people's circadian phase, but there is an excellent questionnaire that's quite accurate, the Munich Chronotype, and there's one or two others as well. So the questionnaires aren't terrible. They're a good enough indication. But then what they did was, people who were late chronotypes, they had them consume their pattern and their distribution of energy had a kind of, like, I think their breakfast was like 20% and dinner was 35%. And then the morning type group was the opposite. The problem with that paper, well, first off, the outcome, both groups lost pretty much the same amount of weight. There was still a slight advantage towards the morning group in terms of differences, but they weren't statistically significant. There was like a kilo difference in weight loss for the morning group, greater. Problem with that study is they did no, like, they didn't publish any of the data on when they ate, the actual clock time. And we don't know anything else about their diet. So we don't have an objective measure of circadian phase, and we don't have any objective time on the clock in terms of did they consume at like 10 or when. So we've no information on that, which is a little disappointing because it was a really interesting concept. So I think that's the next step, is to do, like I said, the previous study that looked at calorie intake relative to someone's internal phase, that was cross-sectional, so it was just comparing the groups. It wasn't I think it would be really interesting to actually see an intervention based on those findings.
Yeah.
An objective assessment of someone's internal phase, and then give them a modified diet based on that relative to their internal phase, but actually monitor that diet and monitor their timing. So have them consume those meals at specific times of day, and let's see what happens with that.
Yeah, measure their differences and measure their differences in natural hunger and ad libitum food intake, I guess, as well, wouldn't it? And blood marker responses, just to have a good look at it. It's all fascinating. I mean, I'm conscious of your time, but I guess that one of the questions a lot of people would be asking would be, what about shift workers? And I mean, we could both laugh and be like, become self-employed. But I mean, in actual fact, like, if people are working through the night, is it best for them to fast, or?
So I'm actually hoping to get a grant. I have an application that I'm working on right now, that will hopefully look at the effects of light, kind of low calorie but high protein based snacking during the night.
Okay.
Currently, the best advice that you could give someone working night shifts absolutely is, don't eat during your biological night. Have a really big substantial meal, even having it slightly later, fine, but if you're having it, certainly in the NHS, for example, I think the average night shift is 9 p.m. to 7 a.m. I'm not sure whether that is the same general pattern in other jobs. I only know that because my dissertation, my MSc, was in NHS night shift workers, nurses. So have a big pre-shift dinner meal, and then try to not eat during the biological night, and consume water, consume caffeine if needs be, and have breakfast then. Have a big breakfast the next morning before going to sleep.
Right.
If you're working like multiple nights in a row. And that will just somewhat keep your internal rhythms on a little bit of track, because the rhythms in your actual, say, your pancreas and your kidneys and those kind of your metabolic organs, they're really strongly influenced by meal timing. So trying not to offset your meal timing too much and not eating during the biological night is the best advice we could give at this point. However, I do really appreciate that there is a psychosocial element to people working night shifts. And there's the stress component, there's the comfort component, there's the fact that you're just awake and you might just want something kind of psychologically to feel like you can keep going. I think this is the basis of my application, actually, but most of the negative effects of consuming food at night relate to our impaired carbohydrate and fat metabolism. And we know that we have a circulating peak in fat, in circulating fat during the biological night. So when we eat on top of that, we get this really exaggerated response.
Right.
That's not great for certainly cardiovascular health. And it may be one of the reasons why over the long term, there's a big increase in heart disease risk. But there's a group of sports nutrition researchers in Holland who've done some research looking at protein digestion during the night as a means of sustaining muscle protein synthesis. And they found that you do completely digest amino acids during the night. So my hypothesis is that if you used low, kind of high protein snacks that are low in carbohydrate and fat, so like non-fat Greek yogurt, or like even a ready to drink protein shake, like one of the grenade shakes, that you would have less negative impacts on your blood lipids and your blood glucose, and that you may somewhat curb next day appetite. So I can't say whether that is going to work because we haven't done the research yet.
Yeah.
But hopefully we'll get some funding for that as a proposal, as a pilot study. But generally that's kind of where I lean to saying, even though, you know, you're filling in the gaps, try to avoid foods that are high in both carbohydrate and fat. And generally speaking, if your glucose tolerance is impaired, the thing that I would avoid eating during the biological night more than anything is high fat foods, because that's coming at the point when our peaks in free fatty acids and triglycerides are happening. If I had to eat something, I'd probably snack on carbohydrate or protein and carbohydrate kind of foods.
Yeah.
If you don't fancy, you know, cold Greek yogurt on a cold December night, you know, on a Saturday evening in a hospital, which I fully understand, you know, trying to kind of opt for something maybe that's, you know, made at home or something like that, and brought in more kind of protein carbohydrate based, and try and keep fats low. But it's really difficult. It's unsatisfactory that we haven't got any advice for a style of work that's not going anywhere. We live in 24-hour societies, and we need nurses, we need doctors, we need firemen, we need, you know, we need people working shifts. So yeah, hopefully I get funding for that, and I'm able to maybe make nutrition advice for night shift work a bit better.
Yeah, that would be mega interesting. Yeah. Well, great. Yeah, I think there's been a lot there for listeners to take away and at least understand a bit more about this emerging body of research. So is there anywhere that you would particularly want to send people, or anything that you want to push at this moment in time?
Not really right now. I mean, I think in terms of, like you mentioned Matthew Walker's book, Why We Sleep, earlier, that's obviously a good book, more specific to sleep. There isn't really anything that's kind of on that level for chrono stuff, because it's historically quite a geeky subject, and there isn't really anything that you can kind of read and be like, oh yeah, this is like, you know, accessible and makes sense. So yeah, I think usually it's going to be through like this, where people are finding out a bit more about it. And I guess Danny Lennon actually has his talk on circadian eating is freely available, isn't it? So
I think so. It's still available on the, because it was part of the Ultimate Evidence-Based Conference, wasn't it? I think they made it a free resource to try and get people to then buy the other ones.
Yeah, I think anyone who's taken an interest in the conversation we've had should probably go there and watch that. I think that would, you know, I saw a similar presentation he gave in Dublin in July, and I think he does a really good job of obviously bringing it all to life, but also I think it really helps to get a visual on some of these things we're talking about.
Yeah.
Like the glucose rhythm, when you see it, you're like, oh. You know?
Yeah, right. Okay, now I understand.
Okay, I'm trying to describe it, and then you see it. Oh yeah, I get it there.
Yeah, totally. No, cool. Great.
Yeah.
Well, thank you very much.
Brilliant. Cheers, Johnny.
I need to